I assume there is no more question. Then let's move on. All right. So we started with kinematics of particles. We study like a rectilinear motion, and we had a bunch of formula. I'm just going to pass through these slides. And then we get to the like curvilinear motion. And for curvilinear motion, we said we can use one of these two systems, either x, y coordinates or t and n coordinates. It depends on the problem. There is not a huge difference between them, but depends on the problem. You will see which one is going to be easier. So we started with XY system. Simply, we said, if you have a curve like this is your path, then you set an origin somewhere like this point O, and it is a fixed origin, and then you set X and Y. X and Y doesn't have to be horizontal and vertical. Depends on the problem. They can be like have any angle. The angle between them is 90 degrees still, but maybe in the future you will deal with a problem that maybe this will be your X axis and this will be your Y axis. So there is then no limit on X and Y and how you choose them. All right. With X and Y, we said for just simplicity, we set some unit vectors. We call this one I and we call this one J. All right, this is just for simplicity. And this, we call them unit vectors. What does it mean? It's if I'm talking about, for example, if I'm saying 5i and my unit is let's say meter, it means that 5 units on x-axis, right? And now if I'm saying, for example, 5i plus 3j, then you know that whatever my unit is, so 5 steps I come here, and then 3 steps I move up, right? So then this is basically the point, let's call it point A. I'm sure you've seen it in math and it's nothing special about it, okay? So with that, let's solve one example. Let me get rid of these. Oh, I see. These zoom things, I need maybe to move it up. Can I do that? Yeah, I can. So, delete. All right. Now this thing is blocking me over there. Okay, let me move it back. Sorry, guys. This is the zoom things. You can imagine somebody like me teaching with blackboards. Need to get used to this tablet. So let's read this example together. We are going to study kinematics of a projectile motion. So projectile motion, it means when we launch something or when we shoot a ball, right? Let's say somewhere. Okay. Let's say over here, I have at this point, maybe a ball for simplicity. And a question tells me that we shoot it with speed u and angle theta. These are the information that we have. So we have, let's say, a ball, and we shoot it with the speed u and angle theta. So let's say maybe this is my initial speed. Let's call it u, and all right, let's call it u. And this is all the information that we have. And the question is asking us to find how high it goes up and what distance it travels. So Let me draw a horizontal line so I can then know what's going on. All right. So this is a horizontal line. Okay. So all of us, we know if you shoot a ball like that, probably it's gonna travel maybe, let's say something like this, right? So this is all the information that we have. And we also know the angle. Maybe to solve this problem, let's use X and Y coordinates. So I'll set my X coordinate then here. Let's say this is X coordinate. And then I'll set my Y coordinate over there. And we know this angle is theta. All right. So we have X and Y. And now to solve this problem, we break this problem to X and Y direction. We treat them independently. So first I will find the components of this U. So it has an X component and it has a Y component. Let's call the X component like over here. And this is the Y component. All right. So we know the X is going to be U cosine theta and Y is going to be U sine theta. All right. Nothing special about it. Now let's study X and Y independently. Let's first start with X direction. Let's study the motion in X direction. All right. So what do we know about X direction? So if there is no external force, nothing to push it. Let's say if it's a rocket, let's assume that it's out of fuel. So there is nothing to push it. Or if it's just a ball, the moment that we hit the ball, then after that, the ball is on its own. There is no external force. There is no, let's say, a fan or something push it, right? And also there is no air resistance. There is nothing. So it means in X direction, we don't have any acceleration, right? So AX then is 0. We don't have any acceleration in X. If we don't have any acceleration, we learned last session, it means the velocity is going to be constant. And if velocity is constant, it means whatever we have at the beginning, it's going to stay the same. So it's going to be equal to V0, whatever we have at the beginning, right? So from here, that's all the information that I have. I can write down then my velocity in X is going to be equal to V0, which here V0 for us means U cosine theta, right? Remember, forget about Y direction. We are just looking at whatever happening in X. And what about position? So remember, always we said we study acceleration, velocity, and position. So we remember again from last lecture, if velocity is constant, right, then X is simply V0t, which here for us, V0 is U cosine theta. Let me write it down like that. So then from here, simply we'll write down X is equal to U cosine theta t. So this is all we need to know about X direction. No acceleration. Velocity in X is U cosine theta and it's constant. There is no time in it. No matter how long does it take, velocity is going to stay the same. And the position is a function of time, U cosine theta and t. All right. So this is all we know about x. Let's go study the y direction. It must be more interesting. So what do we know about y direction? Any idea?
Acceleration is constant.
And how much it is, Felix?
If we're in meters, it's 9.81
Yeah.
meters per second squared.
True, it's g. Yeah. So thanks, Felix. So in y direction, the only things that we know is that we have one acceleration which is coming down, and it is gravity, nothing else. So I will write down ay is equal to minus g, right? Remember, we pick the y-axis to go up. So now acceleration is minus g. So it depends on the axis we pick and the direction. We need to be careful about the sign. So the unit for g can be anything, of course, either in SI or in US unit. And it is constant. So if it is constant, then we know how to treat this problem, right? So acceleration is constant. And we know we have a bunch of formula for these. For example, we know that velocity has this formula if acceleration is constant. At plus v0. So all I need to do now is substitute v by vy, because we're talking about y direction, minus gt. And what is my initial velocity? So you can see it is u sine theta, right? So simply, this is the formula for ay, this is the formula for vy. Now let's figure out how to find y. So we found acceleration, we found velocity, and for y, I'm going to write it down here. We also have a formula that says it is half of at squared plus v0t, right? This is the formula that we know based on the fact that acceleration is constant. So simply, I write down in y direction, I have half of gt squared, because it's negative, I have to carry that minus sign, plus v0 u sine theta t. And that's all we have. All right? Very simple. So we study these projectile motion. Now we have all the equations. We can figure out the rest of things that question is asking us. If you get this point right for this problem, the rest you can simply figure it out, because it's not you. It's the math that solve the problems for you. So for example, it asks us to find the maximum height, right? So these things, we know it's going to travel, it's going to go up, and this is where it gets to the high, and then it's going to come back and jump somewhere on the field. All right. So now what do we know about this ball at the very top? So this is the question. What do we know?
Acceleration equals 0.
No, velocity equals 0. Velocity equals 0.
All right.
Vy.
Okay. So let's see. Kevin said acceleration is 0. Remember, Kevin, acceleration in x is always 0. In y, always is g. Haven't changed, right? And then, sorry, it was Kevin, it was you, or then somebody says about velocity.
That was not me, that was somebody else.
Yeah, no, I know somebody else. So what do we know? Because you said it right. I'm going to go to the chat. Yeah, velocity is 0. So see when these things is traveling, right? It has velocity, it has velocity. The velocity is always tangent to the path, and when it gets to the top, the velocity is going to be horizontal. So when it gets to the top, the velocity is going to be horizontal, right? So then easily we figure out that Vy is 0. We don't have anything in y direction because this ball is not going any further up, right? Right after this point, it's just gonna start coming down. Right before this point, it was going up, but now it's coming down. So at this point, there is no acceleration in y. And you can see from geometry, the velocity is horizontal. So then I would write at the top, Vy is 0. So if Vy is 0, I'll use one of these equations that I have. So minus gt plus u sine theta equal to 0. And I figure out the time it takes for this ball to get to the top. So t is going to be u sine theta divided by g. All right. This is the time it's going to take for this ball to get to the top. Now that I have the time, I can find out like this high, right? So I can, oops, let's use maybe one of these. Okay, so now I can find out like the distance that I have here. Let's call it h. So I have a formula for y, which is this formula. I just replace the time. So h then is going to be half of g, replace t by u sine theta squared plus u sine theta, and then we have u sine theta divided by gravity. So if I simplify this one, I'm going to get u sine theta squared divided by 2g. Am I right? Yeah. So this is the height that this ball is going to travel. Okay. So let's also figure out the distance that this ball is going to travel as well. We are curious to know how far this ball is going. How can we solve that? So we want to find out like this distance. Any idea how we can solve it?
Just multiply the total time by the horizontal velocity.
Yep, we plug the time in x direction, right? So this is what you're suggesting. We'll use, so this is what we are going to find out, x. So you're suggesting, yeah, we plug in the time, and that's correct. So geometrically, we can prove that this path is symmetric. So in other words, we can prove that the time that it takes for this ball to go up is going to be the same time that for this ball for coming down. So the travel time, the total travel time then, from, let's call this point A to point B, is going to be twice as what we calculated up there, 2u sine theta divided by g. Remember, we found the time that it gets to the top, like by this formula. Now the total travel time is going to be twice as that. We have a formula for x. We just replace x, like the time, by this formula. So it's going to be u cosine theta. We replace time by 2u sine theta divided by g, right? We can simplify this formula by u2 divided by g, and sine cosine theta is going to be sine 2 theta, right? You remember it from trigonometry. So you have 2 sine theta cosine theta. It's going to be simplified to sine 2 theta. And we found a bunch of formulas, but you don't need to memorize any of these formulas. You're not going to use these formula. For any other problems, you just write down your own basically equation, because if you study it later, spend more time on it, you see there is nothing special. We just separately in X and Y, we study this problem. Okay. Is there any question, guys, here? So I can stop so we can check if you have a question. If not, okay, let's then move on to the next slide. So this is like an example with some numbers. I'm going to let you to read and think how it can be solved. So it says this boy is throwing a ball, or no, a tool out of this roof, and we want to know what should be its initial speed, v0, so that this ball just pass point B, right? This is the question. So always we start with setting up our X and Y. And for this sort of motion, maybe if you set your origin at the point when the ball is being shot, maybe it makes our life easier. But it doesn't really matter if you set it up, let's say on the ground, then you need to just to be careful about the small constant here and there. So then let's call this one X and then call this one Y. So it's a projectile motion. There is no external force. And this is very similar to previous example, except there is no theta here, right? But we don't care about those formula. We just study these independently. So what do we know about X direction? So in X, all we know is that there is no acceleration, AX is 0, and we know velocity is constant, and always is going to stay V0. Nothing is going to change. And what else we know? If the velocity is constant, then X is going to have an equation like this, V0t, right? What do we know about Y direction? So in Y direction, we know gravity is constant, and we have a formula, right? Half of acceleration squared plus initial speed, right? Be careful here, initial speed has to be in Y direction, Vy0t, which we don't have it here, right? Maybe not to confuse you, let's just write this one as initial velocity multiplied by time, right? Remember the formula that we have? V, the original formula, half of a t squared plus v0t. But here we don't have anything, any basically initial speed. Right? So this is then, this guy is 0. So I ended up with v minus half of g t squared. All right, so this is all we know. Let's see if we can figure out how to solve this problem knowing this information. This is what we know about X, and this is what we know about, oh, sorry, this is Y, right? My mistake. Let me correct it, guys. So this is Y. All right? So when acceleration is constant, Y has this formula. So if I know X and if I know Y, then probably I can figure out how to solve this problem. Let's see what information we have. We know x is equal to 2.4. So at point B, x is 2.4. And y is minus, remember where we put our x and y? This is x and this is y, right? So then it means y is going to be equal to 2.1. And the units, of course, they are meters. Okay, so I have x, I have y. I can figure out then, based on this equation that I have, I can calculate V0, which the question asked me. It's going to give me 3.67 meter per second. All right, I'm going to give you some time to write and also to think. If you have a question, please ask. And as a practice, complete the rest of the problem. So the rest is asking to find out the distance d, which is super easy. You can complete it on your own. Right? So the question is asking about this distance. Any question, guys, or we're good to go? All right, then I assume it's easy for you guys. Then let's go to example number 5. Then I'll give you some time to think about it because I need to do the same. So we know how to solve this problem. All right, so what it says, well, we have a slope with angle theta. So we have this theta here, and this is about the slope. And it says that we have a projectile is fired. Maybe it's a rocket or maybe whatever it is with speed, with velocity u, right? And it says it's a right angle, like this angle here is 90 degrees. And what we want to find out is like this r here. Like we want to find out the distance between point A when we launch this rocket to point B. All right, so this is the distance we want to figure out. All right. So let's solve it together, step by step. First step, always you need x and y axis. So as I suggested, you can have x and y everywhere that you want. But to make your life easier, you'd better set your x and y maybe, again, it depends on the problem, but for most of the problem, if you set it at the point when you launch or fired, whatever question is telling us, the rocket maybe makes it easier. All right, so, okay. So this is then our x and y. So we know that. And then what is the angle that we launch these things with horizontal, right? So if this angle is theta, simply we can figure out this angle must be theta, right? So you can look at this triangle and simply figure it out. It's a right triangle. And if that angle is theta, then this angle is, I'm going to write it down here, 90 minus theta. Now let's get the component of these u, all right? So the component in x and the component in y direction. So what do I have in x and what do I have in y direction? So in x direction, I'm going to get u let me use PEng. Today is the PEng day. U sine theta. And in y, I have u cosine theta. Be careful. Unlike the example before, like now the horizontal is u sine theta and vertical is u cosine theta. That's why I'm suggesting forget about those formula that we developed. Just independently solve the problem. So then you don't make a mistake. All right?
Yes, sir. Could you also use like cosine of 90 minus theta, for example, for the x?
Exactly. So thanks, Kevin. So Kevin's suggesting, can we use, instead of writing that, we just write u cosine of 90 minus theta. This is in fact what I did, but then I was lazy and I just replaced it by u sine theta, right? All right, so this is all the information that we have, and then let's step by step solve it. So in x direction, we know that because there is no acceleration, like ax is 0, then simply I write down x has this formula. X is going to be u sine theta multiplied by t, right? Remember, when you don't have any acceleration, simply, you know the formula, right? When there is no acceleration, it means for you that x is v0 t, which our v0 here is u sine theta. So that's good. This is for our x direction. We figure it out. Let's do the same things for y direction. So in y direction, we know that acceleration is constant, it's g. And immediately we know when things are constant, like acceleration is constant, we have this nice formula for like displacement or position, which is half of a2 plus v0 t, right? So all I need to do, I write down y is equal to half of gt squared plus u cosine theta t, right? Because my initial velocity in y direction is positive, it is in the direction of y, and it is u cosine theta. So I have x, I have y. Now I have to get rid of this time t. If I get rid of time t, I can sort of, from geometry, I can figure out the AB distance, right? I'm just going to give you some time to think how we can find out AB. And then maybe somebody tell me how we can find out AB. This is all the equations that we have. So remember, guys, we figure out like this distance. We figure out that from here to here, this guy is going to travel how much? U, so this is our x, u sine theta t. Also, we figure out this distance, like from here to here, and also from here to here. We figure out that this distance is y is equal, I'm going to write it down here. Half of g t squared plus u cosine t. So any idea how we can continue solving this problem?
Pythagorean theorem.
Pythagorean, yeah, that can be one way, Kevin.
You could also do like cosine theta times x.
Yeah, that's better, I guess, right? So Kevin is suggesting there are two ways, and both are correct. One is to use Pythagorean, and that's true because we have a right angle triangle here, right? And another way is to simply say that, okay, from this triangle, I have some extra information. I know this distance is r cosine theta, and I know this distance is r sine theta, right? So another piece of information. Now we have everything that we need to solve this problem. First, let's get rid of this time because we don't care about time here, right? We just care about the distance. From here, I can find time, which is x u sine theta. Now I replace it here, then y is going to be half of g t squared, which is x u sine theta squared plus u cosine theta and x u sine theta. All right. So now I have this big equation, and it looks ugly, but with the extra piece of information that we have, we can replace x and y with like this r cosine theta that we found, right? Let's do that and see if we get anywhere. So what I'm going to do then, I'm just going to simply replace y by r sine theta, right, is equal to half of g. I'm replacing x with what we just found, which is r cosine theta. And then we have u sine theta squared plus u cosine theta. And then we replace x again, which is r cosine theta.
Professor?
Yes?
Yeah, on the left side, you've written r sine theta as y is equal to minus half gt square plus u cos t.
Right.
So why will it be minus g? Because isn't it in the negative direction? So will it not be positive g?
So in this equation, right? So, you know, gravity is coming down. So we have
I'll actually mark that for you. Wait.
Oh, yes, you're right. That's a
In
very
this
good
one.
point. So thank you, Abhi. So all of us, we forget something. Look at y. So y here, right? This distance, if you look at the axis, is not r sine theta. It has to be negative r sine theta. This is what you're referring to, right?
Yes.
That's a very, very good point. I missed that one. So a good one. So guys, if you look, the y-axis we picked, this distance is below that y-axis. So we have to put that negative sign here. So from here, what can we do? So first of all, the good thing is we can get rid of, like, simplify these things by, like, let's say, can we simplify it by r? Yeah, I guess we can. So let's do that. So this r goes, one of these r then goes, and then so one r here then left, right? And I'll let you guys to continue with the rest and find out r. All right? I guess the rest is just some math. Okay, so is there any question? I'm gonna wait to see if you guys have a question. I'm gonna also check chat to see if somebody has a question. Okay, no question, that's good. All right, so please solve the rest. It's super easy. And let's just quickly, because somebody asked me and I added this extra example here. It looks scary, but it's not really. It is in your practice problems and the solution also is there. I'm just gonna quickly review it. I'll let you guys to read it. For the previous problem, I will complete it after the lecture, so then you can compare your result with mine. And I will post the notes as well. So let's focus. We have 3 more minutes. Let's focus on this problem and see what it asks, right? It looks fancy. Looks like a part of a machine, which later we're going to discuss it with more details. But for now, I just want you to try to visualize. If you want to be successful, like as a manufacturer, you need to practice visualizing things and figuring out how things are working, right? For example, here, let's take this apart. In your mind, disassemble the whole things. If you disassemble it, well, simply you have basically a guide A, this vertical one, this greenish one, and then this brownish or pinkish guide B. So independently, A can go left and right, B can go ups and down, right? And each of them has a slot, right? Now you can visualize if I put a pin between these two, let's say if I only have A, right? A can move this pin left and right. Now when I add B, B move it ups and down. Now if depends on how these two are moving, this point P can have any form, like it can produce any complex form. Like if we put a camera and we check where it goes, maybe we will see maybe this one, this pin P, travel this complex shape. Even this pin can draw a circle for us, right? So even the path can be in a way that when it moves, draw a circle for us. Like if I put my pen there, and depends on how I move X and Y, I can draw a circle. In your tutorial, in your software, you're going to model similar things, but of course, more interesting things. And then you're going to see. And this is sort of base for like later in your future course, you will see for G codes, like you can think of it as more like a CNC in X and Y that it moves, right? But this problem is super, super simple. It gives us X and the motion for X as a function of time, all right? So it says we set up this machine, maybe we have a motor somewhere here, like we have a motor here. This motor rotates, and when it rotates, because it has this gear, which later we will study that, we call it a Warman gear, it moves B ups and down, and also it moves like, why it doesn't work? It moves like X with these equations, X and Y with these equations, right? They are a function of time. Maybe one of them moves faster. You can see Y is maybe moving faster because it has T power 3. So we want to know where this pin is. We want to know its velocity and its acceleration at when after 2 seconds passed. All right. So if I know X, time gone. So I just need 1 more minute, guys. So I know X, which is 20 plus a quarter of T, and simply I can take the derivative. If I take the derivative, X dot is going to be half of T. And 1 more time, then I'm going to get half, right? So this is then my position. This is the velocity Vx, and this is Ax. So I'll do the same for Y direction. In Y direction, I have this function for Y, which is function of time. If I take the derivative of this one, it's going to be 32t, and then Y double dot gives me minus 32, whatever unit they have. All right. So question asks us to find the total velocity, so that this is Vy and this is Ay. So if I want total velocity, then simply it is Vx plus Vy squared. And if I want total acceleration, it's going to be simply Ax plus Ay squared, which we have the numbers because we know t is 2 seconds. We just substitute t by 2, right? So this is the first part of this question, which is super easy. Now I want you guys to go and think and let me know, maybe next lecture, what is the path of this pin looks like? Is it something like this curvature, like this red one that I'm drawing? Or do you think it's going to be something more like this bluish one? Just give it some thought, right? So the question is, we don't know the path. Of course, we can get rid of this time t and find the equation, which later we will do. But for now, based on these values that you have and you will find out, the trick here is that you need to find out the direction of your velocity, right? And this is 32, of course, because we don't have time. And here, this one is 1. You need to figure out if the path is like a curvature, more like this red one, right? Or more like the bluish one. All right, let's guys stop here. I will see you, most of you, in 5 minutes. Not all of you, I guess. Why most of you? All of you in 6 minutes in your tutorial, and not me with your TA, but I will also jump in there to see what's going on, just for the first session to have fun. So, do you guys have any question? Oh, somebody says it's T3. Oh, you're right. Sorry, guys. I rush it through. So it is T3. So it is then 2. Please correct it. I'm going to modify it, correct it. And then this one has to be 64T. Yeah, that's right. Thanks, Cameron. Oh, Felix. Yeah. So it is T3, so the equation are going to be like that. All right, so somebody says it's blue. Let's see what other things. Thanks, Rocky. All right. See you guys later in 5 minutes. Bye for now.
Hello, Professor. Can you hear me?
Yes, go ahead.
Could you please go over the very first question we did, just briefly?
All right. So I just heard
Please.
your voice broken. So you wanna you mentioned this one?
No, the very first one.
This one?
The very first.
Oh, very first example.
Yeah.
This?
I'm so sorry for my mic.
No. That's okay. So this one or not the next one?
The very first one.
Yeah?
No.
Okay, look, this is what we had today, right? So you're not.
The answer was 3.7, I guess.
Oh, okay. So I guess you're referring probably to this problem, right?
Yeah. No. The house one. Yeah, thank you, Akilish.
Yeah, this is the house.
Yeah.
So what is your question?
I did it in a different way, and I got a slightly different answer. First, I calculated the t. My procedure was something like this. I calculated I written like negative 2.1. It has to be equal negative half times t times t squared. From there, I got t, the amount of time that the ball will cover, 2.1 meters. right?
Right.
Then I divided 2.4 to 0.65, and I got 3.69.
3.69, right?
Yeah, I was wondering why did you get like why I got
All right, so
different answer.
I guess what I did, I carry all the numbers, so there is not a huge difference, and in your exam, you're not gonna like, so this answer also is correct, all right? So, as what I did is I like, for this y equation that we have, all right, yeah. I write down minus 2.1 is
equals negative half times.
Then 2.4 divided by V0 squared. This is how you did it, right? And then I solve it all together and I get this number. Like I plug in numbers at once, maybe because you first find something and then you replace it there. Maybe that's why you get it a little different.
I didn't integrate. No, I didn't include a V0 in the equation beforehand, so I didn't include steps. You did in one step, right?
Yeah.
Okay.
Yeah. So that's why you get a different number.
Okay.
That's fine for your exam. Either that way, this small, let's say, accuracy is acceptable.
Okay. What did you take as G? 9.81, right?
Yeah. G always 9.81.
9.81. Okay.
Yeah. Okay. But I will check it later. I guess I did it once in my calculator like that.
Okay. Thank you so much. That was all for me.
Yeah. Have a good day.
Thank you.
Sorry, Professor Heiss. Can I ask a quick question regarding the same question as well?
Yeah, please go ahead.
Thank you. So about this question, I'm just wondering that why we assume that the sign in front of like G is negative instead of being positive, because I'm assuming that like always when we're moving in the direction of the gravity, we need to assume that the acceleration is also positive.
That's
as
right.
Opposed to when we're moving like upward. But in here we're like kind of moving downward. But why in front of half GT squared we put like a negative sign?
The reason is this y direction that we picked. You see here, this y here, right?
Yes.
So this y, I pick it upward. And that's why when I'm replacing the position for point B, which is this position, right? This is point B. So you tell me, what is this distance? This is negative, right? Minus 2.1. Oh, let's get this in. Minus 2.1, right? So both way are correct. If I'm taking y direction going upward, then it means my G is downward. So these two equations has to match, because acceleration now that I pick is against the axis that I picked. But the same problem, if I solve it like that, let's say if, maybe I go with another color. So if I pick X to be this, the same, but Y to be this axis, right? So this is X, this is Y. Then the equation I will write is going to be, Y is going to be half of GT squared.
Oh, that makes sense. So like in the exam, it doesn't matter like what the direction, like what are we choosing as our direction?
Exactly. Because if this gravity is coming down and Y is coming down, these two has to match. This is positive. But later when you substitute the numbers, what is now the position of B based on this pink? So X is the same. Its position is not minus 2.1, it's 2.1, right?
Yes, that makes sense. Thank you so much.
No problem. So you replace 2.1 here rather than this negative one here. All
yes, makes a lot of sense. Thank you so much.
No problem. See you in the Zoom in tutorial.